In this video, we will determine how to identify graph of a polynomial. Like I have a lot of graphs, total 9 graphs. From those graphs, we will identify which one represent a polynomial and which one is not. Now, first we need to know the definition. So, for a polynomial first condition is it has to be continuous. So, to be a polynomial, it has to be continuous. So, first condition is continuous. What does continuous means? Continuous means no jumps or holes. Okay. So, if a function is continuous, then there should be no jump or holes. If you look those graph, for this graph, if you want to move from left end to right end point, from this point to that point, because on the x axis we will move from negative direction to positive direction this way. Okay. So, this way. So, this is the left end point of the graph and this is the right end point of the graph. So, if we want to move from left end point to right end point, so we need to move this direction here, and now to go this graph we have to jump. Okay. So, there is a jump here. So, this is not a continuous function, and this one there is a hole here, because from negative x axis, from this point to that point, if you want to move along the graph, then here there is a hole. So, this is not continuous function. But how about this one? Yeah, this is a continuous function, because if you want to move from left end point to right end point, then without lifting the pen, you can move from left end point to right end point. So, without lifting the pen from the board, if you can move from left point to right end point, then that function is continuous. Like this one, if you want to move from here, then you have to lift the point from the board, then go this direction. So, this is not a continuous function. And second condition is it has to be smooth. Second condition is it has to be smooth. Smooth means no sharp corner, Like if you look at this graph, like this one, so if you go this direction, then after going here, you have to take a sharp turn. Then go this direction. Okay. So, this has a sharp corner, but there should not be no sharp corner for a polynomial. This is actually absolute value function, not a polynomial. And third condition is has no vertical or horizontal asymptote. What does vertical or horizontal asymptote means? Like if you look at this graph, so as x goes to negative infinity, as x approaches negative infinity, then this graph approaches to this red line. Okay. And as x approaches to positive infinity, this graph approaches to this line, red line. So, this red line is horizontal asymptote. This is a horizontal asymptote. Okay. And it should not have also vertical asymptote. So, what does vertical asymptote means? If you look at this graph, this one, So if you approach this red line, then this graph approaches to positive infinity. Okay, and if you approach from right to left, then this graph goes to negative infinity. So this line is a vertical line and it's a vertical asymptote. So this is vertical asymptote. So for a polynomial, it should not have a vertical asymptote. So it has to satisfy these three conditions. First one is it has to be continuous. Second condition is it has to be smooth, that means no sharp corner. And third condition is it has to be like there is no vertical or horizontal asymptote. So now if we consider first one, this one, so this is definitely continuous because without lifting the pen we can move from left endpoint to right endpoint. Is it smooth? Yes, this is also smooth because it doesn't have any sharp corner. Does it have any vertical or horizontal asymptote? No, this one doesn't have any vertical or horizontal asymptote. So it satisfies all of the three conditions. So this is graph of a polynomial. Yes, this is graph of a polynomial. Now number 3, or okay, go number 2. So is it continuous? No, this is not continuous because it has a hole. Because if you want to move from this left endpoint to right endpoint, so if you want to move, then after here you have to lift the pen. You have to lift the pen, then go this way. So this is not continuous. So it doesn't satisfy first condition. If it doesn't satisfy any of these three conditions, then it is not a graph of a polynomial. To be a graph of a polynomial, it has to satisfy all of those three conditions, So this is not graph of a polynomial. How about this one? Is it continuous? Yes, it satisfies first condition. Now, is it smooth? No, this is not smooth because it has a sharp corner here. You go this way, then you have to take. This is a sharp corner. So it has a sharp corner. It has a sharp corner. So this is not graph of a polynomial. So this has sharp corner, so it's not graph of a polynomial. Now number 4, is it continuous function? Yes, this is continuous. We are considering this graph. Okay, this is a continuous function. Then is it smooth? Yes, this is also smooth, but it has a horizontal asymptote. It has a horizontal asymptote, so no, this is not graph of a polynomial. Now number 5, first condition, is it continuous? No, this is not a continuous. So since it doesn't satisfy first condition, so it is not graph of a polynomial. Now for this one, this was number 6. So this one, even it is not continuous. Okay, this is not continuous because from left endpoint to right endpoint, you cannot move without lifting the pen from the board. Okay, so this is not continuous. It doesn't satisfy first condition. It also doesn't satisfy third condition because it has a vertical asymptote. Okay, so this is not graph of a polynomial. So this is not continuous. This has vertical asymptote and this has horizontal asymptote. This is not continuous. Okay. How about that one, number 7? Is it graph of a polynomial? Yes, because it is continuous. This is definitely continuous, and this is also smooth because there is no sharp corner and it doesn't have any vertical or horizontal asymptote. So this is yes, this is graph of a polynomial. Now number 8, is it continuous? Yes, it satisfies first condition. Is it smooth? No, this is not smooth because at this point we have a sharp corner. We have a sharp corner here. Okay, so this has sharp corner, so this is not graph of a polynomial. How about number 9? Is it graph of a polynomial? Yes, this is, because it satisfies all of the 3 conditions. It is continuous, it is smooth, and it doesn't have any vertical or horizontal asymptote. That's it for today's class, this lecture. Thanks for watching.